Hi friends, welcome to my channel. Let's have a look at problem 1992. Find all groups of farmland. In this video, we're going to present two methods or two formats of method. So the first one is the standard depth-first traversal, and the second one is a traversal algorithm along two directions. So this problem asks us to describe a group of farmland in rectangular shape. So let's look at one example. So in example 1, so let's look at the group of farmland corresponding to the 4 ones in the lower right corner. So this 4 ones. So the top left corner has coordinate 1, 1. So this corresponding to here. And the bottom right corner has coordinate 2, 2. So corresponding to these two components in the second component of the return. So for each of the group of farmland, we are required to return such a list describing the top left corner and bottom right corner coordinates. So with that said, let's also have a look at the constraints. So the size of the land is described by m and n. So both the two numbers are bounded in between 1 and 300. So the land consists of 0 and 1s, so this is standard. And the last assumption is that the groups of farmland are rectangular in shape. So this last constraint is important information for this problem. So with that said, let's look at the method we're going to present. So first one is a standard depth-first search traversal. So in this method, we didn't use the shape assumption on the group of farmland. And the second method is a traversal algorithm along two directions. So here we do use the shape assumption. So here are some comments. First, this problem is in essence no different from the problems listed below, like Leetcode problems 1905, 1254, 1020, 733, 200, and so on. So especially if we use standard traversal algorithms to solve this set of problems. So in this specific problem, the key observation is the following. This is the following assumption. So group of farmland is of rectangular shape. So if we iterate in a format like below, say for I in range the rows and for j in range the columns, then we always first meet the top left corner of a group of farmland. So therefore, to locate the bottom right corner, so we just need to see how far we could move starting from the top left corner to the right and to the bottom respectively. So that's basically the second method. So our plan here is the following. First, I'm going to implement a standard depth-first search without using the shape information. So this is going to be a little bit brute force. And then we're going to implement the two-directional traversal algorithm. This is more ideal for the problem at hand. With that said, let's first look at the first method. That is basically a vanilla depth-first search without using the rectangular information. So first, I'm going to track the meta information. So about the rows and columns, that is length, land, the length, land 0. So this is standard. So next, I'm going to write a hyper function. The hyper function is a standard depth-first search hyper. So I'm going to call it DFS ig. So ig will be a coordinates. So I'm going to initialize a set called visited to represent the corresponding farmland or cluster. Then I'm going to initialize a container. Let's see. Let's call it ig. And then we're going to do the standard iteration. That's a while loop. While container. We're going to get the position by container pop. So will visit this position. We're going to add this to the visited site, and then we're going to look at the 4 neighbors of this position. So for xy in r-1c, r+1c, and r c-1, r, let's make it slowly. So r c+1. So then we're going to check if xy is inbound and not visited yet, and is also a land cell. So if 0 less or equal than x less than m, and 0 less or equal than y less than n, and the land xy is a land cell, and also we haven't visited yet, not in visited. We're going to put this to the stack. We use it as the container as a stack. So append xy. So after this while loop, actually we finished. We'll finish or included all the cells in the current group of farmland. So to locate the top left corner and the bottom right corner, actually we just need a sort. So let's see. I'm going to introduce a temp variable. Let's call it temp, the sorted, the visited, and then the return or the top left corner corresponding temp 0. So let me write it like this: 0, temp 0, 1. So these two numbers correspond to the top left corner coordinates. So then let's get the bottom right corner coordinates. That's corresponding to temp -1. So 0, temp -1, so 1. So then we also need to return the cluster or the group of farm itself. So with that said, we finished the implementation of the hyperfunction. So next is we do traversal and prepare the return. So for this, I'm going to initialize a variable called result. So we want to use this variable hold the information. So then we also need a set to aid our traversal. So next is just a standard iteration for I in range m, for g in range m. So if ig not in visited, and also if ig, so let's see, land ig equals 1, and so this not in visited, then we're going to do traversal starting from this position ig. So we're going to return the coordinate pairs and also the farmland. So let's call it DFS ig. And so we're going to append our result with the coordinate pairs, and also we want to enlarge the set with the farmland we have visited. So that's all we need to do for preparing the return. Now let's do the return. So that's a full solution format for this problem. Let's do a special case check here. Yeah, it passes a special case. Now let's do a generic case check. It passes all the cases. So this is one solution, but in this solution we didn't use the information for the shape. So now let's do a second solution. Let's copy these signatures and then mark this as solution V1. So for this, I'm going to what we are going to do is a two-direction traversal. So for this, again, we're going to track the information for the number of rows and number of columns. Let me track this information. m and n are the number of rows and columns respectively. And also we're going to initialize a variable that's called result. This is the first part, and the second part is hyperfunction again. So this hyperfunction will be a two-direction traversal. So for this, I'm going to define it as find edge. So find start to be precise from RC. So if this RC is the top left corner of the group of farmland, then we're going to reset this. Let's see, let me use let's use R2, C2 maybe. So just for then we're going to start from this position, and then we can see how far we can move to the right and to the bottom. Let's first move to the bottom. So while R2 plus 1 is less than m, and land R2 plus 1 and C is 1. Then, so we're going to increment R2 by 1. So this way we can move to the bottom to get the first component of the coordinate for bottom right. So notice that we check the while loop with increment 1, right? So if we exit this one, we're going to get R2 still inbound. So this is the traverse to the bottom. And next we're going to traverse to the right. So basically we are checking if C2 plus 1 is less than n, and land C R and C2 plus 1 is still 1. So if this is the case, so actually we can start from any R here between the R at the very beginning and the final state of R2, right? So, but it's okay here. Then we're going to move to the right. So we're going to increment the C2 variable by 1. So this way, if we get out of the while loop, we're actually able to locate the largest right coordinates. Actually, this coordinate corresponding to the second component of bottom right corner. So then what we're going to do is that, so we want to set all the cells in this rectangular with top left RC and the bottom right R2 C2 by zeros. So this way we're going to avoid repetitions in the following steps. So for I in range R and R2, so we are ending at R2, so we're using R2 plus 1. And for G in range, so C and C2 plus 1, right? Then we're going to make it all 0. So this finishes the main logic. Then we're going to append the corresponding coordinates RC. This is the top left corner, and R2 C2. This is the bottom right corner to the result. So we can think this guy as a traverser or a worker, right? So next, what we're going to do is call the function. Call the function to do the work and prepare the result. So this is basically for I in range M, for G in range M. Then we're going to check if land IG equals 1. So if this is the case, we're going to call this function find at IG, right? So this function will automatically add the list to the result. Then after this, we just need to return the final state of the result variable. So that's actually the full solution for the second format. So let's do a special case check. Yeah, it passes a special case. Now let's do a generic case check. Yeah, it passes all the generic cases. I guess, so this finishes the second method. So let's give a quick summary to end this video. So in this video, we presented two methods. One is a standard depth first search. The other is a traversal along two directions, taking into consideration of the shape assumption in this specific problem. So with that said, I guess that's about it for this video. Thank you so much.